An exciting new feature, create method from acquired scanned data. Now this can be useful in the case of a triple for the situation where you're trying to figure out the compounds or potentially check your method to make sure that those compounds are correct for the quantitation method. So in your method menu you will see new method from acquired scanned data. And that feature I'll demonstrate here in a moment with a pesticide run that has scanned data. First, a little background on this batch. It is scanned data. Here's the total ion chromatogram. And we see down here the extracted ion chromatogram for the various compounds, pesticides in this run. Now, I will admit that this is a GCMS run. You can probably tell that from the word volatile organics here, that has been converted, and we're going to use this as an example. So this is basically the method that's been created, and as we move across the compounds, you'll see from the sample information window the extracted ion signal, and there's, I believe, 37 compounds in this batch that are known with this particular calibration sample. So what we're going to do is to demonstrate how this method could be created using the deconvolution algorithm and applying that algorithm to this chromatogram and setting up a method in a similar way. So let's see what this algorithm can do for us. I'm going to start with a new batch. Obviously there's no method here. I will call this compound perception. We use the word perception because it is really up to the chemist to decide if that is a real compound. So I'm going to add the samples that are in this batch here, and then I'm going to apply this deconvolution algorithm to the whole chromatogram by picking new method from acquired scanned data. Now we'll pick a strong sample, and off it goes to the method editor. And it will apply the deconvolution algorithm, which is quite useful in the case where you have several compounds that are co-eluting. The algorithm will find the target ion and even the qualifiers. And that calculation is similar to the one used in peak purity. It can save you a lot of time when you compare it to manually finding those ions. So here I've got a method where you can see it's picked the extracted ion, and if I look at the qualifiers, you can see that it's for each compound, it's picked a couple of qualifier ions. Here in this case, I see 2 qualifier ions associated with that target ion. Now I'll show you a very similar behavior if I start moving across, and you'll watch the sample information window. You'll see a very similar behavior in the sense that the target ion and the extracted ion is picking up perceived compounds, some of them which co-elute. So I think you can see how useful this tool would be if you had to create a method, and also how it could be useful to check when you have scanned data and are creating a quantitation method that you actually are picking up compounds that are pure. Thank you for your attention.